Hello, everyone. My name is David. I'm a fourth-year student here at BUAS, and as part of my semester project, I spent my time being a Houdini gardener. Oh, shit. Well, unfortunately, I'm not an audio designer, so you'll have to imagine some cool audio effects while this plays. Yeah, so the pillars I set for my project initially were creating a short cinematic of a dandelion growing. I knew the end product was going to stay in Houdini and that it was going to be rendered with Karma. I also tried to make it as photorealistic as I could. My starting point for the project was to create the leaf system. The challenge here was that the leaf changes shape throughout its growth cycle. I needed to be able to blend between these different stages. Since I wanted the system to be adjustable, I didn't want to have to rely on creating manual blend shapes. So I decided initially to disregard the meshing for the time being and solely focus on the silhouette at the start. For this, I chose curves as the starting point, as they allow for full control over the point count used to generate them, allowing for easy blending between the stages. Another advantage of this is that they can easily be mapped to RAM parameters, which allows for flexible user control. After generating these silhouettes, the output was meshed to a single polygon and then remeshed to a triangle mesh. The downside here is that the topology won't be stable and changes throughout the transition, which isn't in itself a problem, but this means that I won't have stable UVs on my geometry. The fix I used for this was to simply project the UVs and scale them with the length of the leaf. This is far from ideal and means there's still some UV sliding, but I thought this was good enough for the texturing approach that I was going to use. The next step was creating the movement. In real life, this is affected by a multitude of different factors, such as light, temperature, humidity. Effectively, this means the plant is in constant change, which is further exaggerated by the fact that it's supposed to be a time-lapse. To emulate this, a series of bend deforms is used, using different sign expressions, governing the frequency and amplitude of the movement. In addition to that, a layer of noise is added on top, using channel operators to add some variation. The leaves and their animation are then copied to points, and their growth offset by time shifting each leaf. At this point, all the leaves are still intersecting each other. In order to solve this, I opted to go with a vellum cloth simulation on top of the animation that I had made. Since the leaves themselves have inconsistent topology, I needed to generate a proxy for each leaf instead and run the simulation on this. Afterwards, the non-deformed proxy, the simulated proxy, and the non-deformed leaf geometry can be used in a point deform to apply the simulation. As there are sometimes errors where the proxy deviates, such as at the base of the stems, an attribute is used to mask out these areas. The vellum sim is set up such that it follows the animated geometry, but the constraints are still flexible enough that it can deviate from its original path from colliding with other leaves. The result is that the leaves now grow without passing through each other. After generating the leaves, a trail node is used to aggregate all the positions of the leaf geometry, which can be then used to find all non-intersecting paths which form the basis of the stem geometry. The stem growth is animated using a carve node and then applying deformation similar to the leaves. Afterwards, these stems simply get meshed and hair gets scattered on the geometry. For creating the blooming flower, I initially also used bend deformers to control the petal movement. However, this didn't give me as much control over the shape as I wanted, so I decided to switch to a rig-based system instead. In this case, the rig is simply a line for each petal and its corresponding stigma. These then get scattered on points which have an animated bloom attribute. This attribute drives the blend between the three rig poses. Additionally, the petals are also rotated outwards during the blending. And on top of the animated petals, another vellum simulation is applied, with a de-intersection stage added beforehand to make sure that they don't intersect when the flower opens. Texturing is done mainly through creating patterns in Copernicus, and then using different geometry masks to apply those textures to different parts. The advantage of using these geometry masks is that they also change alongside the growing geometry, and they can easily be remapped and reused to apply color gradients or displacement maps. To finalize the flower, I also added secondary and tertiary petals to complete the flower bud, and I reused the bloom system to add the seeds of the clock stage. All right, that concludes my presentation. Thank you for listening and enjoy the rest of the talk.
Okay. Huge thanks for the presentation. Next is Roxana, and talking about embroidery.
Mike, for clear on Mike.
All right. Hello, everyone. My name is Roxana Moshashai. I am a 3D character artist, and today I'm going to talk to you about procedural embroidery in Substance 3D. And the reason for that is because I personally just love embroidery, and since it is such a complex topic, it really needs a non-destructive workflow, in my opinion. However, most of the methods usually focus on thread embroidery, which is the one you can see here, but there's also like beadwork, which I personally love, and I wanted to find a method to do all sorts of like beadwork or all sorts of embroidery in just to find a way to create garments like this, for example, in a very easy and intuitive way. And the way I did it was I created a tool in Substance Designer, and these are the very simple graphs that I have created. No crazy spaghetti. It's honestly like the simplest graphs I have ever created, honestly. And the reason why they can be so simple is because all of the magic is actually happening inside of Substance Painter, because those graphs are being used as two filters to either fill areas with embroidery or add embroidered borders to areas. And here are some examples that I have created. Those are all rendered in Unreal Engine. And like I said, those are all done by me, but at the end of this presentation, I'm also going to show some examples from my testers. And if you wonder what testers, this was actually an iterative process. I have created 3 versions of this tool that have been tested 34 times by 26 testers, which were all character artists, either students or professionals working in the industry. And without further ado, let's look at how the tool works in action. It uses images to turn them into embroidery, and there's different types of inputs that you can use. And to establish the direction of the embroidery, I found a very easy solution of like just being able to brush it into the correct direction. And this also works with path brushes, which are also editable, so it's actually even more non-destructive. And here it is for the border mode, which just uses the same inputs and adds a border around your design. And since this is Substance Painter, after all, you can also just paint your embroidery. here using path brushes, for example. And the way it works is everything revolves around a shape splatter node, which is this part of the graph. And that just spawns the height of the embroidery, and then the color is being added. And then for the type of embroidery, it references a separate graph where all of the information is stored. And by selecting which input you use, you can use different types of embroidery that I have also shown in the video before. And then you can also add roughness variation. This is a bit extreme, but it's just for showing purposes. And then for the border mode, it's actually even simpler. It just takes the area, uses a mask to paths node, turns it into splines, and then just scatters the information on the spline for the height and for the color. And since it uses the same, it references the same graph, you also have, you can also use the different types of embroidery. And here is how it looks inside of Substance Painter. Those are the two filters. And the reason why it is a filter is because while it was used as a material, which is a more common way to use graphs inside of Substance Painter, you needed to reference a separate layer and use anchor points to reference that information for your material. And that was just a bit complex. And I turned it into a filter which can be applied directly to the layer, so you don't need anchor points anymore. And while it was such a small change, it actually made a very big difference in ease of understanding for the users. So, yeah. And the way it works, the way it works is that it takes the different channels of the layer it has been applied to, which is this part of the graph. And it just turns those, for example, it uses the base color channel for the color of the embroidery. It uses the metallic channel for the mask, and that's how it looks. For example, this can be your layer, your color channel of your layer. This is the metallic channel of your layer, and then it turns it into the embroidery. And the normal channel is used for the flow or direction of the embroidery threads, which by default, all of them are going to run parallel to each other, but that's not very accurate. That's not how embroidery usually works. So by using two brushes that are provided with the filters, you can just brush the direction into place, which I have shown in the video before. And the way that this works is that it, depending on the direction that you're moving the brush is going to draw in a different color. And then Substance Designer is going to read that information and turn it into the direction of the embroidery in that area. And as I have promised, here are some of the examples from my testers. Everyone was having a lot of fun with it. So, yeah. Thank you so much.
Thank you. That was fantastic. Oksana is one of our master students. Now we have Valentino next. Here you go.
All right. Hello, everyone. My name is Valentina. I am a third-year technical art student here at BOAS, and today I will be presenting to you my procedural rice fields tools made in Houdini and Unreal Engine 5. So firstly, we have two types of rice fields. So as this was a school project, we were asked to follow a prompt, which was realistic Edo period Japan. I was very inspired by the rural landscape of Japan, and so I decided to do rice fields because rice farming is a big part of that. And so I have two types: rice terraces for the more slopey areas, and then flat fields for the more village areas. So firstly, here are the references I used. For these references, it was crucial that I pick accurate references from Japan. And so I aided myself by using Google Maps and taking aerial shots. I also needed to keep in mind the historical accuracy as well, since modern-day farming is very different from the techniques used in the Edo period. So firstly, I will start with explaining the pipeline for the terraces. So for this tool, the user paints a mask on a terrain in Unreal, which will guide the generation of the rice fields. I then use scriptable tools for the interface, which then creates the HDA and finally bakes the final result into a landscape, foliage, and water planes. So here is a sped up version of the tool in usage. We can see the user is painting the mask on the terrain, and there are also other parameters, such as choosing the type of crops or water shader to be used, as you can see here, which gives great control over the look of the rice fields. And you can also give it a random seed to have different field patterns, as you can see here. So here's a quick breakdown of the tool in Houdini. First off, I start by smoothing out the base terrain to have a good base to work on. And then I use the height field terrace node to create the terraces, obviously. It was quite a balancing act to find a good step size though, because the smaller the step size is, the smoother the slopes are. And so I had to make sure the terraces were short enough to fit the references. So it was a lot of trial and error. But then comes the interesting part. The terraces as they are right now are quite boring, they're straight and smooth, and what we want is some variation. So now, as we see on the references, there are some kind of overlaps between the basins, and some parts actually aren't rice fields at all. For this, I created the Voronoi noise pattern using cops, which I then overlay as a mask on top of the terrain. Thanks to this mask, I'm able to mask out the areas that will become basins. I then convert my height field into a mesh, which, yes, it's kind of slow, but not that slow actually. And then thanks to a vex wrangle, I'm able to keep the mask information stored on the mesh. Thanks to this, I'm able to lower the masked out parts so they can become basins. And then finally, I scatter the crops, add the water planes, and separate the different landscape layers so they can be used in the Unreal Landscape material. So now let's move on to the flat fields. So this tool is very similar to terraces, except instead of painting in a mask, the user places cubes in the level instead. The world input, unfortunately, didn't work in the scriptable tools interface for this one, so I didn't use a scriptable tool here and just used the HDA interface. All right, so here again you can see the tool usage in action. The parameters are very similar to the terraces as well, the difference being that you can choose the amount of subdivisions you want, and again, it's highly customizable. Again, we're back in Houdini. So while this looks simple enough, a lot of vex actually went into this one, especially with subdivisions and conversions from mesh to height field. So if you want to know more, you're welcome to ask me during the questions or after the talk is over. But essentially, this version creates all the subdivisions and basins while it's still a mesh, and then the rest of the work, like the workflow, like adding the crops and water, is done after it is converted back into a height field. So we're coming to an end of this presentation, but first off, I like to reflect on what I could have done better. So firstly, there are some issues with flat fields sometimes merging into each other, but fortunately, that is an easy fix in Vex. I'd also like to find a way to get the world inputs working in the scriptable tools interface for the flat fields. And finally, I've noticed the terrace basins can get a little thin when the slopes are too steep, but that can also be easily fixed with a mask by feature node. And this is it. I'm currently looking for a technical arts internship starting September 2025. You can also scan the QR code to find all of my socials, and you can also scan the other QR code here to find a Rookies article I also wrote about those rice fields, which goes into a lot more detail about all the prototyping steps and iterations that went into this. And yeah, of course, you are more than welcome to talk to me after the talks. And you can also ask me about other projects that I've worked on, as you can see here. And yeah, thank you.
Thank you, Valentina. Valentina started as a programmer, and then after a year where I'm teaching, she decided enough of that, I want to do art. So
yeah, technical art is pretty cool.
Right. Okay, Andrea, you next. You ready?
Yeah.
Okay.
Oh, let's see. Oh, yeah, that works. So, welcome to my presentation about an organic grid system in Unreal. It's meant for the editor.
I'm going to talk about how I attempted to do this, where I kind of fell, and what the final result from that is. So first, just briefly about me, I used to work as an automation technician, so coming from the electrical field, and I always had this itch to be more creative, composing music, painting, and also making games. So I decided to go study here at Breda University. One of the things that I'm really interested in is making city building tools and just making that ease for everyone to be creative and realize the vision. I was very inspired by games such as Tinyglade and Townscaper, but also early on by Spore, Trackmania, and other games that had these elements where I could build my own vision, right? So I started doing that. However, I kind of early on met my worst enemy, which pretty much was overscope, as you might imagine. So on this quest that became a campaign, I started by, trying to find the secret sauce on procedural generation. And it was rather overwhelming. And at some point, I was like, I got to start somewhere. And I learned enough to narrow it down. So I was thinking I should just start by making the layout of the city, right? Not thinking much about the buildings themselves, but just the layout. My first attempt was with Houdini. It has some bunch of amazing nodes, right? You might have seen the quad remesh, which works great with those organic grids. Thank you, Simon. And I used like the terrain layers and painting masks to sort of get a layout going. But I kind of quickly realized that there's just a ton of parameters. It's complex to work with. And it wasn't the direction I wanted to go into, like enabling designers to create their vision, not mine. So I looked at Townscape and was like, oh, cool, let's do this in Unreal. And I used what I learned from Houdini and Quad Remesh. Again, the placement, the complexity, it just grew and grew and grew and grew. So I was a little bit stuck. I looked at Houdini, I looked at Unreal, I was like, what do I do? So as an automation technician, I came from this field and was like, I always have to solve an issue. And then I started thinking the other way around, and it's like, oh, I could look at how people interact with something and then solve the issue based on that. So thinking, how does the user interact with it? What can I do to help them with working with that issue? And so this brings us to my last attempt, which was over the course of 8 weeks. I started by trying some different methods, and this was the final result. You just draw a spline. I create a grid from that, which is just offsetting the spline. And I sample then those offsets like a onion, right, on a right angle to create an area. And you can just place more and more and then extrude it, and you have your building shapes. This was very simple, and because it's always the right angle, the intersections work very well with each other. So what does it do? Well, you can start blocking out an entire city as like this natural flow. You have full control over the entire thing, and you can change and iterate on it. And you can also add rules to guide the city design process, and you can use the splines as landmarks, which is also like the roads, the bridges, and derive everything from that. So it's all integrated into the editor and the city building itself. This might be repeating it, but just how the tool works: you draw a spline, you place the building block, and then you can move and scale it around however you want. So it's very simple. Just on a brief note, I was considering using assigned distance fields to kind of calculate the offsets, which had some benefits of also solving like the intersections and overlaps, but they ended up going with some simpler things to make the offsets. So just another way of doing it. On a final note on the tool, it uses blueprints and PCG only. I didn't code any C++. The reason for that is just I didn't need it. It might not be as fast, but the generation time is spread out over the interactions, so it doesn't really matter that much, and nobody noticed that. However, it does have a slight precision error over time, over the outlines, and also sharp angles, as you might imagine, don't quite work that well. So briefly on what's next, this is just a blockout tool, so I'm trying to put some more, things that are actually useful on top of it, which is at the moment like a modern roof, as well as figuring out how the walls could work with decorating it. And that's pretty much it. Thank you for your attention. You can have it back now.
Yeah. Thank you. We had actually two options to choose from Andrea. One was the one that you saw, and the other one was on procedural audio. So if you are curious about either one of those, you can reach to Andrea during the break. Next one is Jan.
All right. Hello, everyone. My name is Jan Prochaska. I'm a third-year technical art student here at BUAS, and today I'll be presenting a toolkit designed for user-friendly HDA and tool management in Unreal Engine, and how it supports and streamlines our game production process. So, what problem does this toolkit actually solve? As tech artists working on game projects, we often create HDAs that would be incredibly useful for the rest of the team. However, we don't have time to onboard people on them. So we manually create these widgets with Houdini Engine's node library to build a user-friendly UI, but managing multiple widgets can quickly become a mess. So this toolkit is designed to solve that exact problem while streamlining tool distribution, usage, maintenance, so that the teams can focus more on the production side and less on the pipeline overhead. So how do we actually add tools to the toolkit? The toolkit is primarily focused on HDAs with mesh or instancer outputs. Other than that, the developer can create the HDAs as normal. When the HDA is ready, they need to generate a parameter JSON file for which I've created a custom exporter node. And then the developer assigns the HDA and the JSON file to a data asset, and they define how the tool should behave. They can also enable some additional functionality I'll get back to later. Now I'll go over how the individual tools get constructed. So based on the created data asset, the toolkit assigns a tool into the correct category and creates a button for that tool. Then it creates a wrapper with basic controls like spawn, update, bake, and delete. Inside of this wrapper, it creates appropriate parameter and input UI. And at this point, the toolkit is done deploying the tool, but the developer can enable those additional features I mentioned. One of those features is chaining the tools together, which means when you have multiple tools in the toolkit and you know their results are compatible, you can link them together. This can happen quite often as you keep adding tools to the toolkit during the development process. As an example of where chaining could be useful, I have this building tool ready to be baked, so we decide to bake with the Ivy tool. The Ivy tool gets inputs assigned and we can continue editing. Because of this feature, we can seamlessly continue using multiple tools in a row, and the user doesn't need to know which tools are compatible or not. Adding more scriptability is something I've implemented based on feedback I've got of where this toolkit could be limiting. So based on the data asset, the developer can add additional widgets, and those widgets can provide additional functionality in areas which cannot really be generalized or automated. As an example, I have this tool which relies on processed and cached landscape. In this case, the widget blocks the usage of the tool until the cache exists. And once the landscape has been cached, it unlocks the tool and allows the user to use it as expected. So generally speaking, those widgets could be used to grab some extra data from the scene or to manipulate the behavior of the tools themselves during the processing process. So now what happens when you start manipulating the tool as a user? When the user triggers the spawn button, toolkit sets a safe location and some outliner conventions. Then the toolkit registers a new active tool within its UI and assigns the correct inputs, and we can continue editing. When editing, the user can switch between multiple spawn tools. This allows the user to have a clear picture of what tools are currently active and allows them to manipulate multiple tools within the same UI. Now for the restoration part, if the user wants to revisit the tool because part of the level needs to change or tool gets updated, the restore actor finds a specific tool within the toolkit and reinstantiates the tool in the same location. with the saved parameters and inputs. And it also updates the tool if necessary. To streamline this restoring process, we can spawn a bounding box within which we can restore all of the tools within the area, and the user can continue editing. Now for a small conclusion of this project. It's been a great experience working on this toolkit and deploying it in a team. Development loop got a lot better because of this framework, which I'm really happy about. In the game we're currently working on, we have around 300 stored tools around the scene, which is cool to see. And huge thank you to my team members, especially Alison, Evelyn, Jurgi, and Jolan for providing me with some assets for the tools and letting me use them as a background for this presentation. Because this was a fairly high-level overview of how the toolkit works, if you're interested, please check out my ArtStation. I have some deep dives about the toolkit there. And if you have any questions, feel free to reach out to me on LinkedIn or just catch me around the conference. Thank you.
Okay, thank you. Next is Shah. You ready?
I'm totally ready.
Okay,
All right.
we'll try to have a micro talk with a live demo in it in 6 minutes. Let's see how it goes.
Yeah, let's see. I have 3 live demos actually, so 3 times the chance that something explodes. Yeah, so I'm Shad. I'm a research software engineer at TU Delft. I build games for monkeys and make sure that robot arms don't strangle people. I'm also a game developer. I built this little game here. It's basically Portal, but then with gravity shifting. If you like to check it out, please do. Sorry for the shameless plug, but I really like money. This is what I want to show today. So basically, this is something I did for my master thesis under supervision of Rafael Bidara, who's also sitting somewhere here. Basically, we wanted to look at how we can make WFC into a companion in a tile editor. And we had to make some modifications to WFC to make this really work. Now, of course, I assume a lot of you are familiar with wave function collapse, so I'm not going to fully explain it. It's a really cool algorithm. You just give it a bunch of tiles and constraints and a grid, and it will fill this grid according to the constraints. So that's the promise it gives you. Now, I had to change this algorithm a little bit by adding 2 more buzzwords to it. So we have a whole mouthful here, which will do really well in academia. But I also want to explain what exactly, of course, this means. Now, first of all, the semantic part is, so we have this, well, it's not showing, but we have these new types of tiles called meta tiles. And what they basically do is they can represent other tiles, and they can also represent each other. So now you're no longer only generating these very highly detailed tiles, but these meta tiles. And you can also paint with them. So you can isolate semantic concepts. You can create this tree yourself, and then you can actually paint with these things so you can more intentfully do stuff. And then we organize these into a hierarchy. So you get this thing where it goes from very low detail to high detail. And the root tile is basically the God tile, so it can become anything. Now it's time for a live demo. Let's see how this goes. I should first find the correct tab. Can I get some help? Oh yeah, okay, sorry. Yeah, I don't use a Mac, so it's a bit... Oh yeah, it is.
You just put it on that screen and then it will come.
That's fine. All right. Now, first to show you why using just WFC is a bit annoying. So we have here a little generator. It's really fast. I should make it a bit slower. Made the algorithm too optimized, I guess. Okay, so the problem here really is that if you want to place a tile, then you suddenly have to think about which exact tile you need to place. Say you want to build a little house here. Now suddenly, oh wait, we cannot place this because this is the top left inner corner wall. Okay, so we need to find, I guess, bottom left outer wall. Oh, now we can do something. And now the same thing happens when you want to extend it further. So this is kind of annoying to work with. So this is an example of having a tile set with these meta tiles. What you can now do is basically say like, oh, hey, I want a little village here, I want a little forest here, and I want some water to split them. And you can paint it like that, and it will generate. And because we use these meta tiles, we can also just like we have all these basically sort of references to things. So these, for instance, this village consists of little houses. So we can say like just regenerate the houses for us, and it will just regenerate those for you. And you can get different shapes like that. We can also play with the probabilities. For instance, if we say we want to make trees a little bit less common and then regenerate the trees for us. Oh, sorry, not the trees, the forests. You can do something like this, and it will make a forest much less, full. Now, something else that's also really cool is that WFC has these constraints, of course, that it adheres to. So if you want to build a house in the middle of the water, it won't let you. So it will first surround by grass and then by sand. And this is really a little bit the things that you can do. You can sort of make these design templates with these high-level tiles, and you can actually keep regenerating that several times to get all kinds of variations. Yeah, I'm not going to show the third demo. It's going to be too much. But I can show that, for instance. So, and you can also go as detailed as you want. For instance, if you say, I just want a wall here for whatever gameplay purposes, and we save this, you can regenerate this many times you want, and it will always give you some different result, but it will respect those things that you specified there with those high-level tiles. How do I get back to the presentation? Oh yeah, it's cool. So that was the live demo. Yeah, there's some potential future work because we have this whole hierarchy of things. We know exactly what belongs to what. For instance, we know whether a house belongs to a particular village or not. You can do all kinds of fun things on this with connected component analysis, and then have these instances. For instance, boundary conditions for the brush strokes would also be nice. So you can have like a house contained within the brush stroke, for instance. By the way, these meta hierarchies you can just completely build yourself. That was basically the third demo, but it will also be really cool to derive them using AI just from an image. So you get this already completely ready to use tile set. And of course, we could bring this to 3D. Now, that was my talk. If you scan this QR code, it will bring you to the landing page, which has all these editors and also all the background literature and how the algorithm exactly works. Yeah, check it out. And if you have any questions, please let me know in the break. Thank you.
Thank you. Okay. Next is Seb.
Hello, everyone. My name is Seb, and today I will be presenting to you my procedural billboard system. So this is a system that procedurally generates billboards, but I am also deploying a lot of procedural tools to control what is exactly being displayed on the billboards themselves. And in this case, it's mainly through the form of advertisements. And my favorite part about this is the way it's generating text. So that is what I will be talking about today. But before I move on to that, I want to give a bit of context on the billboards themselves. The billboards are generated with a simple spline in Unreal, and with interactive 2, you can control how wide they are, how deep they are, and how tall they are. And this is all done through Houdini. I'm using a bit of geometry script in Unreal as well, and a lot of blueprinting. But the way I'm generating my billboards right now gives me a little bit of problem when it comes to generating my text. And that is mainly that in my advertisements, I want to have text that is dynamically updated when the game is running, and I want the text to follow my billboards themselves. But this is a bit of problematic because normally we would use text actors for that, but those are flat and they cannot wrap around the billboards that I'm generating. So I started thinking, okay, what if instead of Unreal text actors, I started using textures and then update these textures. See if I can play this video. Instead of that I start using textures, and then I update those textures in runtime and then put those on my billboards. But those give me problems as well, because if I have these really long billboards with really long pieces of text that I'm scrolling through, I need to have very big textures, or I have to sacrifice texture resolution for all my characters, which is also something that is not preferable for me. So I started thinking, what if instead of these two methods, I'm sorry. What if instead of using these two textures, I generate all of my text directly in the shader instead? So this is the pipeline I came up with for that. It's based on a texture called the font atlas, and this contains all the glyphs and characters of the alphabet that I need to create my pieces of text. And then with some really precise and smart UV sampling techniques, I very specifically sample each character in this font atlas in such a way that it draws the text that I want. And so I started building that, and the first step of that was to build the font atlas themselves. Sure, I could go into Photoshop and create this all manually by hand, but if an art director were to come up to me and told me that they wanted to use a different font, I have to restart all over again, which I do not want to do. So instead, I created a Python tool that does this for me. It's exposed to a simple interface in Unreal, and all I have to do is give it a font file, the font characters that I want in my font atlas, and it just generates a texture for me. Optionally, it also packs all of the characters in the RGBA channels of the texture, so I can make optimal use of the texture space that I have. But still, I have my font atlas. I still need to tell my texture, or I still need to tell my shader what text I want to use. And there's no text inputs for shaders on Unreal. So I need to go with my next best alternative, which is textures themselves. And I kind of confusingly call these text textures. And what they do is inside of its pixels, it encodes the characters that I want to use. So if, for example, if you look at the first 2 pixels of my text texture here, you can see how it stores in this RGBA channels the UV coordinates of the characters and size, alongside with several other properties that are needed to draw out my text in my shader. Of course, I'm still not generating these or creating these manually by hand. I have created a tool for that. I created even 2 tools for that. The first one is a simple tool through an interface in Unreal. You just feed it the text that you want and the font that you want to use it with, and it spits out the texture for you. But this is only used for static textures, which is not what I want. I want to update my textures in runtime. So I created another version for this that exists in blueprint format. And this comes in the form of a custom node that I made in C++. And similarly to the other tool, you just need to feed it the text and the font you want to use it for, and it generates the texture for you. And this texture only exists in memory, so it's perfect for updating it in runtime. The last step in the process is to bring everything into the shader. And I created a custom material function for that. You can see that in the top right of the screen. What this does, it takes a look at all of the UV coordinates that are encoded into the text texture and then converts them to actual UV coordinates that the texture sampler can understand. And as I explained earlier, these textures, or the UVs, sample my font atlas in such a way that it selects all of the characters and then puts them next to each other. And the user doesn't have to worry about this. It all happens inside of the material function. So to quickly demonstrate how this looks from a user perspective, you first start off with generating a front atlas. You tell the what characters you want to use, and it creates a texture for you. Next step is you go to the text texture tool, albeit it blueprints or this user interface. You tell what text you want to draw, and it creates a text texture for you. And the last step is to bring everything into the shader with the custom material functions and the textures. And if you wait for a bit, and there it is. We have text generated directly in the shader. So to reflect on this for a little bit, I'm happy that I solved my problem, but I cannot help but feel that I created an overly complex solution to a problem that should be very simple. Still, I haven't found a better solution, and there might be a much simpler solution for it out there, and I will feel very silly if there is. But that said, I still learned a ton. I learned a lot about blueprints, Python, a bit of C++ as well. And maybe being a tech artist also means that you need to, or that you get stuck at really silly stuff. That's the end of my presentation. Thank you all so much for listening. This is only a smaller piece in a bigger puzzle. The Billboards has much more stuff to offer. So if you want to learn more about it, you can scan the UR code and check out my portfolio, or ask me questions later, now or during the conference. I'm also looking for employment opportunities. So if you also want to chat about that, I'm open to that as well. Thank you.
Thank you very much. Next is Sahar.
Right. So, hi everyone. My name is Sahar. I'm a third-year student here at BOAS, and today I would love to present you one of my latest projects, which is a tool to generate animals procedurally. Close. As broad as it sounds, with this tool you'll be able to generate the skeleton, skin, muscles, rig, animation, and muscle simulation. And because all of this happens procedurally, the workflow is non-destructive, meaning you can go back and forth, do changes as much as you want at any stage of the process. How it works is that we start off by adjusting the skeleton. When we are satisfied with that, we simply press generate muscles. Then we might adjust the muscles a bit. We press generate a skin. And after that, the rig gets generated for us. And then we might want to do some animation. And after the animation is done, the muscle simulation automatically gets calculated too. A little bit about the progress, starting off with the skeleton and bones. Some general controls are provided for example, the height of the limbs, the length of the body or the width of the body. But for more details over the skeleton, you can directly move the joints in the viewport. So since the skeleton is the base for everything, I knew the more anatomically accurate this is, I'm going to have better result later on. So I tried to implement the most important features to this. And so for example, you can see that the pelvis and the scapula are adjusting automatically. I don't know why it's not playing anymore. Anyway, and also the spine gets adjusted automatically too. Next step was to generate the muscles, and I would say this was the most challenging part of the whole project because I needed to study into anatomy, which was very new for me. And I also wanted to have very realistic result, which required me to have very precise planning and research. As expected, my first step was to try to find out what are the similarities and what are the main differences between different species. But my main focus throughout all this time has been mostly mammals. I made several versions. Here I'm showcasing one of my first iterations where I made a muscle generator where a piece of muscle gets attached to any given geometry. The problem that I ran into with this workflow was that I was getting a lot of muscle intersections. I later developed a tool to avoid that, but the more I continued with this workflow, I saw I'm not really getting realistic results with this. So I decided to scrap this and search for better workflows. So while developing the system, I had my anatomy book where I'm collecting a series of studies on different animals. I would then go compare and examine my results with these. And each time, starting from new, I carried a better understanding and knowledge about anatomy and muscle structure in general. And I found that there is a certain pattern of dependencies between muscles with themselves and also with the bones. And this was like a puzzle that I had to figure out. It was like as if I had to find a map, a set of formulas. And how I knew that I have found the right formula was through doing a lot of testing in different scenarios. So for instance, I would try to generate portions of the muscles for different animals, take notes and try to improve on those. In general, we can say that muscle structure for all animals have a lot of similarities, but also there are quite many differences. So it's impossible to have one model that would work in every scenario. And the solution to that was to provide a set of controls that would allow the user to achieve what they want. And all in all, we can quickly and easily achieve very realistic results now. Next step is to generate the skin. This gets generated based on the muscles that we made before. For the moment, the user needs to provide the head geometry because that was almost impossible to make it procedural for all the animals and all the species. But when the geometry is input, inputted, the neck muscles get adjusted automatically to it. So yeah, the rig is procedurally generated in KineFX as well, and it contains IK and FK controls. The animation is procedural too, and the rig, the animation is transferable from rig to rig. So for example, if you have a walk cycle of an animal and you generate other animals, the animation from the first animal is transferable to the rest. Next, we have muscle simulation. This section of the tool is very much under development, but the idea for it is to have a nice space for muscle, tissue, and skin simulation, which needs to all happen procedurally. As a result of the tool, every individual muscle comes with their own muscle ID, and also the properties of the muscle, for example, muscle to muscle, muscle to bone constraints, and muscle ends are also corrected, which instead of having to paint individually every muscle, if we were to follow the normal workflow of a muscle simulation. Here I'm showcasing two of the tools I developed to help me with the process. The one on the left side is a tool to avoid intersection between muscles. The one on the right side is I'm showing how I'm making the tension lines. Procedurally, the tension lines are used for muscle flex. And again, if the CFX artists have had to do this following the normal workflow, they would have to go manually draw every single of these lines. So the tool is meant to make the character artist job a bit easier. So they will be able to quickly and easily make different variation of animals. And they can also take these models into ZBrush or any other 3D software, maybe do some adjustment to them. And then if they bring it back to Houdini, the tool will generate a skin, rig, or whatever you want. So moving on, I see this project as something that can be endlessly improved. So I'm planning to continue working on this. I have added features such as adding multiple limbs to the animals, but I want to add more details like that. I want to continue to perfect the anatomy. Right now, it works really good for mammals, but as you can see here, it's not really working for lizard type of animals. I want to also improve the topology, and I will continue on working on simulation as well. And with that, my presentation comes to an end. Thank you so much.
A huge thanks to Sahar for anyone that thought that the jelly presentation from last year cannot be one up. Sahar proved that you managed to to be the star again. Fantastic. We have one extra student. It's me. I'm the extra student. I've recently started a research into procedural level design. This is kind of the name of my topic, and what I'm looking for is to see what does it take to empower game designers to build their own generators, and seeing that I'm in a room filled with a lot of people that are experts in PCG or are moving towards that. I would like to get your opinions and get a survey so that it kind of guides the direction that I will go in the next years. Everything that I will create will be released under open access, and every bit of code that I write will be on GitHub, and I will develop open source. So I will also share the link. So if you miss it, I will put it in Discord. Now going back to the stars of the last hour. Do you have any questions for any of the students that were presenting? And they can all come to stage so that they can share the mic and answer the question.
Hello, my name is Robert. Trying to talk to the billboard man himself. Seb, is it?
Hello.
Howdy. First of all, I've run into that same issue of yours as Unreal and text issues. The only way I found to get around it was use a widget and then apply that as material. But then I couldn't update the text in real time because for whatever reason it would work as a widget, but it would not work as a widget attached to a material unless if I was like moving in game. So I was wondering, I don't know if I missed this in your presentation, but with your billboard text, I know that you have like, yeah, you had the long string of text and that's why you wanted to move the text into the material. Is it updatable in real time, or do you actually have to have it kind of preset so that way the texture is already baked in?
With my method, it is indeed updatable in real time because you can also generate the text through a custom blueprint node, which creates like a memory-only texture that you can dynamically change in real time.
Thank you.
Hi, I have a question for Shad. Yeah. So I was wondering, with your wave function collapse systems, how do you deal with cases where you have made a semantic model, a semantic version of the map, but you don't have the right tile for the place? Maybe you briefly scanned over that part, but I was wondering if you could elaborate on that part, because that seems like the most problematic part of WC.
Yeah, that's a very valid point. So currently it does actually highlight when it runs into contradiction, so that gives you a hint to, okay, my tile set is probably incomplete. Yeah, you will have to supply those tiles. I think it's very nice to look into how we can communicate this to designers more effectively, right? I believe I saw a Unity asset that also used wave function collapse for creating your own kit that actually really looked into this, into how we can communicate to the user that you're missing particular tiles in your tile set. So that's something to look into.
And chances are the maker of that Unity plugin is somewhere here in the crowd.
Yeah, if you're here, let's have a chat.
Okay.
This is for Seb with the procedural billboards, because I presented my city earlier and I have billboards there. So I ran into that same exact problem of rendering text into a texture. And there is a simpler way to do it, actually.
I would love to hear it.
So like, the way I do it is I hide a camera somewhere where it's not visible. And in front of that camera, there's like a little box, a little just plane with a text component on top of it, and then the camera takes a snapshot and just saves it as a render target. That's it.
Yeah, I really like that solution as well, but for me, this didn't work with really long text because then you have to need really big texture size render targets.
No, mine is like 512 or something by 512, and seems to be enough.
Okay, thank you.
My question is for Sahar. Thank you for your presentation.
Thank you.
It looks like you are mostly focused on quadrupeds, mammals, right?
Yeah.
I was wondering how flexible is the system, say, were we to add wings to the quadruped to make it turn into a dragon or an extra limb? Would the system adopt, or is it kind of rules are fixed to the quadruped specifically?
Yeah, so right now I'm working on adding more limbs to animals, but I also have planned to add wings later on. So the bird anatomy is a little bit different, so I will need to do adjustment not only to the muscles, but I will have to also do it for the skeleton too. It will need a little bit of tweaking, but I see it possible.
Thank you.
I don't see any more questions. Thank you very much, all the students. Yeah. I think this is just a trick to keep me running.
Yeah, I just wanted to mess with you. Sorry. So this is also for Sahar. Great talk. Thank you very much. I was wondering, you mentioned this pipeline of exporting the muscles and modifying them elsewhere, such as zebras, and then re-importing them. Could you just talk a little bit more about that and where you're at with that progress?
Yeah, so for example, if you take the muscles if you export them, the muscles have their own muscle ID. So they are individual objects. As long as you don't combine them while you bring them into ZBrush or whatever, as long as they stay as one object, when you bring it back, the tool will recognize that, and then it will proceed to do the rest.
Thank you. Okay, I will assume that that was really the last question. So one applause for the student. And not to forget that they're all searching for an internship or for employment. So find them with some interesting opportunities behind.